Let's take a look here at the inelastic collisions that we could do in the glider lab. So just to give you the setup for the lab itself, we had glider 1 and we had glider 2. And in this case, what we had was this one had an initial velocity that we measured with the smart timer that we put here, smart timer in the photo gate. So we had the smart timer here, if I can get it to right. We had the smart timer there, but we had no other smart timer. So the collision occurred, right? I'm using the little colons to represent the collision occurred. After the collision, we had objects 1 and 2 stuck together, moving with the velocity. All right. So let's assume that the masses are equal to 0.2 kilograms, and figure out what would happen whenever we start the velocity of 1 initially at 2 meters per second, and the velocity of 2 initially is equal to 0. What would be the final velocity of these two moving together at the end? Because since they're together, we can treat them as one unit. Alright, so again, it's this setup right here with these variables. Alright, so the momentum before, as always, the momentum initially equals the momentum finally. The momentum initially is equal to the sum of these two momentums. So m1 v1I plus m2 v2I. Now the momentum finally is equal to this unit. Now, since they're stuck together, we can assume that we can add them together. So m1 plus m2 times a final velocity. They should have the same final velocity. Alright, now plug in numbers. v2I is 0, so that goes away. So we're left with 0.2 times 2 equals 0.2 plus 0.2 times Vf. So we end up with 0.4 equals 0.4 Vf divided by 0.4, and we get the final velocity is equal to 1 meter per second. Now this is the way to solve for the velocity. But as you may note, there is another thing, the mass. How would you solve for the mass? Alright, so let's look at another problem. So in this one, let's say that we have glider 1 coming in at 5 meters per second, and glider 2 is stationary initially. Alright, glider 2 is stationary initially. So we don't know what glider 2 is. Glider 2 has a velocity of 0. Now, they collide, and glider 1 and glider 2 are together, and they move with a velocity of 3 meters per second. This way. Okay. Now we need to know what I'm going to tell you is that the mass of glider 2 is equal to 2 kilograms. What would need to be the mass of glider 1 to make this work, to make this system work? In this case, obviously, we're solving for the masses. We know the velocities. We want to find the masses. So work it out extraordinarily similarly. So we know that the initial momentum equals the final momentum, just like we did before. Alright, so we know that this momentum plus this momentum add up to equal the initial momentum. Alright, so m1 v1I plus m2 v2I equals the momentum finally. Since they're stuck together, alright, we have to add them together. We put the masses together. m1 plus m2 final velocity. Now, we don't know what m1 is, but we know its initial velocity is 5. So we plug it in, m1 times 5 plus m2 times 0 equals, by the way, m2 was 2 kilograms. So now we know that m1 is unknown still, plus 2 times the final velocity of 3. Alright, now we are going to solve for m1. So the first thing I'm going to do is I'm going to FOIL this. So I'm going to put 3m1 plus 6 equals 5m1. Alright, solving for m1. I'm going to subtract 3m1 to the other side. Minus 3m1. So I'm going to get 2m1 equals 6. And then I am going to divide by 2, and I'm going to get m1 equals 3 kilograms. Now just to check if that worked, all right, let's plug it back in up here, see if it works. Let's see, 3 plus 2 and 3 here. So 3 times 5 is 15, and 3 plus 2 times 3, 3 plus 2 is 5, times 3 is 15. So it worked out. Everything worked out good. Momentum initially equaled momentum finally. All right? Inelastic collisions. This is also how you would work it out, how to find the mass if you didn't have the mass. Okay?